Assalamualaikum and a very good morning. So today we are going to continue chapter 4, which is on data presentation system. So for this topic, chapter 4 is that the LO will cover LO3, which is analyze, selection and integration of mechatronic component. So after you have gone through this topic, student will be able to explain the requirements of data presentation system, and student able to select the suitable data presentation system for a mechatronic system. So let's just do a recap on what are the three main block diagram under mechatronic system. So the first one is that we have the measurement system. Second is that we have the actuation system. And third is that we have the whole block, which is we call as the control system. So what you have learned up to today is that you have learned on chapter 2, which is on sensor and transducer, types of sensors, and the working principle. And for chapter 3, you have learned about signal conditioning, which can be applied for both measurement system and actuation system. So what we are going to learn today is on the data presentation system, which is one part of the measurement system. So where are you going to actually put the data presentation system? So there are two ways how to integrate it into this mechatronic control system. First option is that to apply it directly after the actuator as an indicator. So it means that you can actually apply this as alarm, or you can add it directly after the measurement system here. This one as a recorder. So you are going to record all the data from the sensor after going through all the signal conditioning, amplifiers, filtering, and A to D. Then you are going to record it. And from this data will be useful for the control design later on. So as mentioned, in the measurement system, you will have the quantity being measured as the input, and you have the value of quantity as the output. So from the input plot diagram is that it's going to be connected to the sensor and transducer. So for example, quantity being measured. Example, if you want to measure the rotation, so you need a sensor to actually measure the rotation. So you may want to implement a displacement sensor, and based on this, it's either rotary or linear. So this is just to read what types of quantity being measured. And from here is that the data need to have signal conditioning. So you may want to amplify it, want to filter it if there's noise, or you want to have the protection circuit inside here. So it's up to you, okay, based on the requirement of the system. And lastly is that based on the signal that has been amplified, filtered, you are going to display it using a data presentation system. Okay, so this is where you can actually see what is the value that is being measured. So chapter 2 you have done on the sensor and transducer, and for chapter 3 you have done on the signal conditioning. So let's just look at the simple block of a measurement system. So first, you will start here. You have the physical signal. So it's being read by the sensor or transducer. And in this part is that you have all of the signal conditioning. Okay, so this is all signal conditioning. If you see here, you have the analog processing, which is in analog signal. Then if there is multiple signal 1, 2, and 3, you may want to have use a multiplexer. And then because it's in analog and your computer only can read in digital signal in binary, so you want to have a analog to digital converter. And only after it's converted to digital output, then it can only be read by the computer. And a computer is also one of the type of data presentation system. So this is where you can display your data, and you can record your data. If you see here, okay, you can either display or record. So this is where you can directly look at the graph, or if the data is required to be processed for the next control process, so you may want it to actually convert it back again from digital to analog. So it's going to give a feedback to the system. Recap of the function of each block diagram. So we have covered sensor and transducer block. So the function of sensor is to produce a signal relating to the element which quantity is being measured. So note here is that all sensors are transducer, but some transducer may not be censored. So this one I have explained in class for chapter 2 in the previous class on sensor and transducer. So element of sensor, it can be displacement, position, proximity. So if you see here displacement, proximity, and position, it might be similar, but it has different function. Then you have velocity and motion sensor, force sensor, fluid pressure sensor, liquid flow sensor, liquid level sensor, temperature and light sensor. Okay, temperature and light sensor look similar, but it has different function. And next block is the signal conditioning block. So the function is the process signal to make the process signal suitable for the next operation. Means that if either you want to record it or you want to collect the data for the next process control. So example is that getting the level of signal right, which is either you want to amplify it from millivolt to voltage, or you want to eliminate or reduce noises using filter, or you want to get the right signal, type of signal. It's either in analog or digital. You may want it to have a linear signal. So if it's a non-linear type signal, non-linear like this, you have a signal like this, you may want to actually convert it into a linear signal. And the fifth one is on protection. So by if the device is sensitive, so you may want to add fuses or current limiter for safety reason. So this element total was 8 types of signal conditioning you have learned in chapter 3. So for today is that you are going to learn about the data presentation system. So the function is to display and record data. So example is you have the display element, data presentation element, example graph, oscilloscope, magnetic recording, display, dark means it's either dark, you have learned it also in the signal conditioning, and then the testing and calibration. And after this, you are going to learn about types of actuators. So you have 4 main actuators. You have hydraulic, pneumatic, electrical actuators, and mechanism. So normally, mechanism means mechanical actuator. Mechanical actuator. So actuator is something, the function is transforming output of a control system into a control action. Means that to convert it from rotary or from a signal to a motion. Last, in the introduction to mechatronics is that you are going to learn about control architecture. So some control function is that to control some variable to a particular value. So we call this as reference. Or you want to control the sequence of an event. So this is normally you will use PLC, okay, programmable logic controller. Or you might want to look at either if the system can be controlled or not. So if it's you are not required to have a closed loop, so you can just let it be an open loop system. Or if you want to have you want to control it at a certain references or certain value, so you may want to have a closed loop system. So for the data presentation system, there are wide range of elements that can be used for data presentation, but traditionally it's going to be divided into two groups, which is the first one is indicators and the second one will be the recorders. So indicator means that it directly gives instant visual indication of the sense variable. So for example, if there is an alarm or warning system, okay, normally you will hear an alarm, a buzzer, alarm going off. So that one is known as indicator, directly giving you an instant indication. Or normally you will see a light blinking if there's a warning system. So that means a visual indication. And recorder means that you're able to record the output signal over a period of time, and this will give you a permanent record. So it means that you can able to collect the data, and later on you able to actually plot the graph over a period of time. So this is the most important thing in data presentation system. Especially nowadays, we are talking about Industry Revolution 4.0. So both of this is important. And for the recorder, and it can be divided into two types, which is the analog and also the digital. So we have first is the indicators. So you see that for this indicator is that to give an instant visual indication of the sense variable. So for example, you can see a display there or an alarm. So let's look at Andon system in the manufacturing. So Andon system is actually a visual system that has been used in Japan. So they call it as Andon. So I will play the video. And next is the recorders. So recorders is to record output signal over a period of time to give a permanent record. So basically you need to have you will able to collect high speed data. So for example, the sampling time of the data is 1 millisecond or 0.1 millisecond. So imagine that for over a period of 1 minute, you have sampling of 1 millisecond. It means that every 1 millisecond you have the data for 1 minute. And then you can collect, based on that, you can collect large data because of you have this sampling time. And essential record means that after you collect all the data is that you can further process it to use for controlling and for display. So the next example for display is loading. So loading is the effect of connecting a load across the output terminals. So for example, if you are going to connect an ammeter into a circuit or connecting a voltage across a resistance. So example, if you have this ammeter, okay, you are going to actually connect it in across this voltage. So therefore, this is named as loading. So let's say that you have a sensor over here on the left side, and then you are connecting the sensor to the amplifier, for example, to enhance the signals. And then lastly is that you're going to connect this amplifier to a display or a ammeter or voltmeter. So when you actually measure it from this point to this point, you are actually adding a additional load to the output. So this in terms will actually, by connecting an ammeter into a circuit, it actually makes the measurement of the circuit change the resistance of the circuit, and so therefore changes the current. So you can do self-learning activity for this one by referring to the PDF that I have attached in ULearn. So you can read on page 92 to 93. So that page is from the main textbook. So this is an example of a display by using loading concept. So you have this loading concept. So this is where you're going to attach the load at the end of the Zener diode. So for example, if you have a high voltage, okay, in the circuit, and you actually attach it in the wrong polarity, so what happens is that you can add Zener diode circuit and a fuse here. So what happens is that after 5.1 volt, which is for the Zener diode rating, so the Zener diode will break down and conduct current to the ground. Okay, so you have the ground here. So load will actually go up to 5 volt. So when the Zener diode is 5 volt. So this is what example. So when it breaks down means that the fuse will actually short. Okay, so this is one example of adding a loading at the end of the circuit. For the displays or in the data representation system, there are few types of meter that can be used. So the first one will be the analog meter, which is for low input resistance, and second one will be the digital meter, which is for the high input resistance. So the commonly used meters are, first one is the moving coil meter, where you have a point moving across the scale. So this one I will explain later in the next slide. And another one is that we have a digital voltmeter, so which is you can read the voltage in form of sequence of digit. So for the moving coil meter, okay, it's an analog indicator with a pointer moving across it. So I think you have seen this before. So you have a pointer at this end, so it's going to move from 0 until the rating. So for example 5 amp. Okay, so you have the positive and negative polarity here. So normally is the positive, and this one is for the ground. So if let's say that we have this, how does the principle of the moving coil meter? So for example, you have the voltage applying to this circuit, okay, north and south. So meaning that you have the positive polarity, positive minus. So you have the current flowing through. Sorry, it's a different direction. So you have the plus and minus over here. So you have the current moving from here until here. So what happens is that when current flow, this will cause magnetic field to exist between the field coils. So you have the magnetic field here. Okay, it's going to move between this coil. Okay, so when this happens is that this will cause the pointer to turn. So for example, the initial position of this pointer is at 0, means that at 0 position we say in the middle. So when you have the current motion, so it's going to actually attract the pointer to move in this direction. So what happens that this pointer is going to move this direction. So you can see that the more current you apply, then it's going to move to the positive position. Okay, so this is how the principle of the moving coil meter. So let's look at the digital voltmeter. So digital voltmeter is a meter that which gives reading in the form of sequence digit. So by using this digital voltmeter is actually, you can actually eliminate the parallax error and give high accuracy reading. So it means that parallax error is something that if you were to actually have the analog meter, so you have the pointer, okay, pointer, it's pointing at 0. So you have the reading here 15 minus 15. So you need to look directly from the top view. So this is your eye, so you are looking directly at the top view. If you were looking at the side with an angle, so you are going to read a different value. Means that maybe instead of 1, you are reading it at 0.1 milliamp. So example, so by having this digital voltmeter, you actually remove the parallax error. Okay, so where for digital voltmeter is that you're going to have the inner output similar to what you have for the analog voltmeter, but in addition to that, you're going to have the sample and hold. So sample and hold is something like what you have read in the sample and hold is something that you have learned in chapter 3, signal conditioning, which is from analog to digital converter. So you have the analog to digital. So sample and hold is something that you hold the value at a certain sampling time. So you need to have the sampling time. So for example, sampling time is taken at 1 millisecond. Okay, so therefore you will actually convert it from analog to digital. So this is why you have the ADC here, and then next is the counter. Counter is actually to display this value. So next we will look at the 7-segment display. Okay, so from here is that just take a few minutes to go through this. So find out or explain the principle or operation of a digital voltmeter. You can refer to the PDF file that I have shared to you, or you can go to search it in the internet by searching it in Google, or you can just search it in YouTube. Find a video that is relevant to the explanation of digital voltmeter. And other than the voltmeter and analog voltmeter, so there are another type of display is the analog chart recorder. So basically there are 3 types of analog chart recorder, which is the direct reading recorder, galvanometric recorder, and and third one is the potentiometer recorder. So do some self-learning here activity. Okay, 2, read page 95 to 96 and try to explain with your own word what does it mean by direct reading recorder, what does it mean by galvanometer recorder, and does it mean by potentiometer recorder. Okay, if possible, try to draw out how does it work, what is the principle of the recorders. And other than that, we also have the cathode ray acceleration. So normally you have seen this in the lab, and you have the visual display unit, VDU. So if you remember, you have seen this in a video that I've showed to you in the beginning of week 1. I've showed to you the video on the job scope of a mechatronics engineer. So we have seen that the engineer was walking through the production line, and he went to repair one of the visual display unit, VDU. So if you see here, this VDU has so many components of this data presentation here. You have the monitor, you have the indicator. Okay, what else? You have the deck card also inside here. So lots of data presentation inside here. Okay, and mostly you will find this in the production line. So you have even in each of process in the production lines. Example in the wire bond process, in the die attach process, and some other processes that is to actually collect data and to display the data and to analyze the data for quality. And the third one is that printer. This one is what you have normally look at. Nowadays we don't actually use printer. Okay, if you want to actually record something, you can directly use a handphone to actually scan using your camera. So nowadays people do not require printer or scanner. You can always use your handphone to actually scan it. Okay, so this one, but I would say that normally in research we do prefer recording of data on papers. Why? It's for backup. For instance, if your laptop is broken or was stolen, so at least you have a recorded data which is on paper. So from there you do not need to start from scratch. And next is on data storage. So this data storage is mainly by magnetic recording. So it's used for data storage on floppy disk and hard disk of computer. So I'm not sure if nowadays you know what is floppy disk. So it's the black thing, okay, large, and then you have the middle part here. Okay, so you insert into the disk. Okay, so nowadays we don't have this floppy disk. Now we have the USB drive and so on. Okay, or CD. CD is also not being used much nowadays. Okay, and there are various type of magnetic recording method. So we have total 5. So go through this activity 3, okay, and read page 102 in the PDF. Okay, and go through and try to explain it. The working principle of this magnetic recording method. So what does it mean by non-return to zero? What does it mean by phase encoding? What does it mean by frequency modulation, modified frequency modulation, and run length limit? Okay, so this will be some self-learning other than referring to what I have explained in this video. And lastly but not least is the display. So most display system, example, light indicators to indicate on and off status, give alphanumerical display numbers. Okay, so for example, that is commonly used, or you have seen it in most of the traffic light, is the 7-segment display. And second one is the LED display. Okay, you can see that it's either blinking. Okay, so we use the LED display, or you may use the liquid crystal display. So this one is relay on reflected light or transmitted light, or LCD. So monitor, LCD monitor, and so on. And fourth one is alarm indication. So this is the common use of display. For example, if you want to have a direct warning for some, so alarm, temperature alarm, current alarm, voltage alarm, weight alarm. Okay, so these are the things that actually required together: display and also the data presentation. Okay, this is an example, like in Tokyo we have lots of LCD displays, okay, at the building. Okay, very bright at night. We have the 7-segment display. Okay, and also this one is also common type of LCD display. So for 7-segment display is that you have it actually read from the binary input, okay, from 0000, and then it's going to be converted to the segment activated value, so from A to G. So where is A? A is this value, A, B, C, D, E, F, and G. So example, so binary input, if you have a binary input 000, what it means by that is that it's going to convert it to the segment activation, means that it's going to display number 0. So you have the value for A, B, C, D, E, F is 1 and G is 0. So you have this value activated, so it will display 0, number 0. And if you were to activate the display number 1, so means that if 1 is that, you need to have the value B and C. So B and C. So this one will actually equivalent to the binary input 0001 and so forth. So this one is an example of using the 7-segment display. And last but not least is the data acquisition system, data logger. So you have learned in the signal conditioning is that one of the important signal condition is that DAQ card. Okay, so this here is where you actually automate the data DAQ system, and it can be taken in the form of instrumentation. For example, computer with plug-in board. So computer with plug-in board is something that if you see in your normal PC, you have the board or motherboard. Then second one is the data logger. So if you were to look into the flow of how the DAQ being collected, so you have the physical data, you need to have the sensor here, then you go to the signal conditioning, and then from this value is sensor is in analog, so you're going to convert from analog to digital, and in digital you are going to display here. So what you are learning in this chapter is on the display and decision making, so displaying it. And if you were to take this value and you would like to actually feedback it to the input, so you're going to convert it back from digital to analog, and then from analog to this actuation is that you're going to amplify or reduce the value. So you're going to use a amplifier or filtering signal to filter it and sending it to the actuation. Okay, so and this is just show an example how you are going to connect it from the similar like what in the previous slide. So system with the input from sensor and will be displayed by a computer. So if you have a sensor or transducer here, so if you bought a sensor, so how do you actually display it onto a LCD or onto your computer? So you first of all you need to consider what is the next step after sensor. So sensor, the reading is in analog. So because of that, you need to look at into the signal. Is the signal in very small value? So if it's small value in millivolts, so you need to amplify it, or if it's too much noise, then you need to use a filter. So this is where the signal need to go through the signal conditioning. Okay, then after doing the signal conditioning, is going to go through the DAC board. So DAC board is the where the signal from the physical signal is going to enter into the computer. So this is where you need to have a DAC board. Okay, DAC board. And because you need to display it through a monitor, so you need to have a data presentation. So for this case is that you have a monitor or you need to have a software to actually display it. Okay, so a simple way how to actually display your graph, if you have a system and you run the experiment, then you collect all the data. So how to display that data is by using LabVIEW or MATLAB. For normally in control we are using MATLAB, and we can actually display our graph in the oscilloscope in the Simulink. So how do you actually set what is the step to use the DAC? Okay, so first of all is that you need to define the input signal. So define first what are the analog signal, input signal here. So normally the input signal what we are talking about is the signal from the sensor. So is it in direct current, is it in time domain or frequency domain? So this time domain and frequency domain, just ignore it for this round. So later on when you are learning signal system, you will know detail what does it mean by time domain and frequency domain. So from here is that you will see that all of it are in analog. Okay, so you need to convert it to analog to digital. Okay, and from here is that when you convert it to analog to digital is that if it's a DC, then you directly will look at the value in DC. But if it's time domain, then you will find out that there are some types of shape or graph that you're going to plot. And for frequency domain is that you're going to look at in terms of the frequency. Okay, frequency in hertz value here. And the second step is to actually add the signal conditioning. So let's say you have the transducer or signal at the left side here. So you see that there are all of these are sensors. You have the thermocouple, RTD, strain gauge. You have the common mode or high voltages. You have the load requiring AC switching, signal, high frequency. So all of these are transducer. So next step is by adding signal conditioning. So you may want to add an amplifier. You want to add a isolation or protection. You want to add a filtering. Okay, and after adding this signal conditioning is that last step is going to a DAC board. Even though DAC board is a part of the signal condition, but we declare it as an additional to the signal conditioning. And the third one is that connecting from sensor and transducer, okay, to the signal conditioning, and then lastly is to the DAC board. Okay, so some configuration before connecting the cable is that the nature of the signal sources. Okay, so check if it's grounded or need to be floating. So normally your signal source need to be grounded. Okay, second one is that the grounding configuration of the amplifier, signal conditioner, hardware and network. So make sure that you have connected the cable of each grounding for amplifier and signal condition is the correct grounding, and do not actually connect to the wrong polarity. Okay, and third one is that the cabling scheme to connect all the components together. So make sure that to connect the sensors to the signal conditioning or to the circuit or to the dashboard, remember you need to read the data sheet. Okay, example data sheet that I have given to you in the chapter 2 on sensor and transducer. I have given to you the exercises where you are given a data sheet and you need to go through the requirement, okay, of selecting a sensor. So in the data sheet you may see that there's a connection, how to actually connect the sensor to a circuit. Okay, which polarity is the correct circuit, or connecting it to the correct port. Okay, so just a recap. So we have seen this before. So this figure before. So we have the physical phenomena here. So you can actually connect any transducer at the end here, and then you're going to connect it first transducer. Second is on the signal conditioning. So signal that may go here is either voltage or current. Normally that is the signal that you're going to collect from this signal conditioning or from the sensor. And next is the cabling. As mentioned, the cabling, make sure that the cable is well grounded. Okay, the amplifier or the signal conditioning amplifiers or filtering is well grounded. And lastly is to connect it to the dashboard before you display it on the display unit. Okay, and for testing and calibration is that there are 3 stages in testing a measurement system, which is fall into three. So first is that pre-installation test. So for this one is that to test for correct calibration before installing. Second is piping and cabling testing. So this is to check leak-free test before sensor are installed. Okay, and third one is commissioning. So this is test is done after installation is complete before full operation. So there are 3 main stages. Pre-installation is something like, for example, you have bought a sensor, so you're going to test first that the sensor is working according to the data sheet. Okay, and after doing the pre-checking or pre-installation, then you are going to connect it to the system. So after you connect it, you're going to check first if the system that is connected, the sensor which is connected to the system is able to collect the reading. Okay, and the third one is that pre-commissioning is that test is done after installation, so for full operation. Okay, so there are 3 stages. After the full commissioning is where you will run your experiment and get running it for example 24 hours or collecting data for analysis. And for calibration is that it consists of comparing the output of measurement system and its subsystem against standard of known accuracy. Okay, means that you know what is the accuracy of the sensor. Okay, from the data sheet. So calibrate is something that you check. You are going to check it in a period of 6 months or 1 year, and to check that the output is the same with the datasheet. If it's not the same, that you're going to calibrate it, send it out for calibration, or you can calibrate on your own. Okay, example of equipment that you need to have a calibration is the voltmeter, ammeter, load cell, and pressure sensor. So all of these need to have a calibration from time to time. Okay, so please go through the main textbook page. I shared to you the PDF, so go through the main textbook and read through page 92 to 121. Okay, so that will be all for chapter 4. Thank you very much.